Alright, so I'll start with an intro myself. My name is Alex from Python. Today I'll be speaking on infrastructure as code with Python. So, what's the name again, please? Daniel. So, just like I and Daniel were discussing the other time, currently at the moment, using the ClickUps approach to set up any kind of instance. Now, AWS, GCP, or Azure, right? You can also do this via CLI, right? But what we get into today is how we can embed how we do this in our native Python code. How we can create and have yes instance with same Python code, right? That we're using to write, our backend APIs. So that means that if you have a backend path now that requires a Redis instance, a PostgreSQL instance, you can now write the IAC inside your Python script. You don't need to define it elsewhere. And one of the big benefits of this is that you don't have to learn anything new just for you to be able to do this. So we're going to be looking at some of the features of IAC, and then we'll look at some popular tools that we can use to write IAC in Python. So now let's get to the details. What is IAC? IAC is all about handling and setting up computing infrastructure using files that machine can read instead of relying on manual setup or programs. So just like he currently said it does provision his instance right now. Let's take Terraform for example. I could write a Terraform script that actually automates provisioning that EC2 instance. But now with CDK, which is the cloud development kit tool that allows us to write this IAC in different programming language. It means now I don't need to learn Terraform or even know any Terraform syntax just for me to be able to do IAC. So I'm not doing that. So it means I can now do IAC with the normal Python knowledge I know of today without having to learn how the syntax of Terraform work or CloudFormation works basically. So moving on to the features of IAC. One of the features of IAC is consistency. And consistency ensures reliable, secure, and efficient infrastructure, leading to stable and scalable solutions. So now that we can declare, can set up our infra declaratively, it means we can say, oh, I want to create an RDS on, let's say, a default VPC. You define your desired state, and it is the job of the IAC to bring up your resources to meet your desired state. Right? That's one of the benefits. And also, so let's say we define the configuration file that maybe do some basic setup for us or whichever. It means this configuration file will be consistent across any environment. So unlike the normal ClickUps approach that is prone to error, you can easily forget, some command line you were running in your after you set up your EC2 instance and you try to remember that. But with IAC, you can easily automate all of these things and they can easily be carried over to any environment. So you are rest assured that your dev, staging, production environment are identical, right? Now the next one is version control. So it means just like we version control our code base at the moment, just like we version control our backend apps, our front-end apps, it means we can now apply this same method into how we actually provision our infra. So it means I can write a bunch of infra scripts that probably set up an RDS instance, and I could group them in branches. I could say, oh, this develop this main, this feature branch, whatever, right? That way, it helps, it enables teams to collaborate with each other and also help bring everyone on the same page. Why? Because the IAC to provision your resources is written in Python. It means if your dev team is made up of, let's say, mostly Python devs, it means you guys can actually write IAC yourself even without a dev engineer. So I've actually put up a couple of a sample project in Python, right? I think this is off. You guys can still hear me, that's fine. Okay, so I've actually put up a sample project using some of these popular tools that we look at, which is the Terraform CDK, AWS CDK, and Pulumi CDK. So I'm going to be running some of the scripts that I've put together in the demo shortly. So let's move on to the next item on the list, which is idempotency. Idempotency allows our infra deployment to be run multiple times without changing the results. So this basically means, so let's take for example now, let's say we just finished writing a script that set up a database, but that's not enough. When you create a database, you need a default user to use to it. So we write a script that set up a DB, and also create a default user on that DB. What idempotency does for us is when we run this code multiple times, when we run this script multiple times, it will detect if the changes have already been applied, and it will skip it if it's already been applied. And if it's not, it's going to definitely create the results and bring it up to your desired state that you have defined. And by desired state, I mean if you specify that you want an EC2 instance of T3 micro or any kind of EC2 instance, the rest assured that I have to provision your resource to meet whatever you specify in your configuration file. So yeah, leveraging of the existing tool chain. So just like we use pip to manage dependency, we use npm to manage dependency, we write tests for our code. It means we can now do the same thing now on how we provision our infra now. So because we cannot write, we cannot define the state of our infra using Python. It means you can use your native pip manager that you use to manage your dependency in your code. So to actually manage the infrastructure as well. And also, we won't have to learn any new tool. So the barrier to pick up is actually not there. So meaning you just need to actually just check the documentation to get the details of how it works. So moving on, why Python for IAC? Python has a rich ecosystem of libraries such as 3, Ansible, AWS CDK, and the likes of them. Right? I actually do have an example in the demo on Boto3. Boto3 is a very powerful Python library that gives us low-level access into AWS APIs. So we can use that to do, a whole lot of these things, a whole lot of these IAC tools are still like wrappers around, libraries like this. So if you actually want to interact AWS API or maybe one Defender's API, you can, for AWS, I know of Boto3, which is like a very popular Python library. And yes, Python is now a very strong community, and I believe that's why we're here today. So yeah, let's take a look at some of the popular tools that we can use to write IAC. We have the AWS Cloud Development Kit. The AWS Cloud Development Kit allows us to define infrastructure using familiar languages, either Python, either JavaScript, Golang, and the rest of them. And it deploys them using Cloud Function. So like I said earlier on, instead of you having to go learn, what is Cloud Function, or how do I define an RDS instance in Cloud Function, it means you cannot write this in Python instead of having to go like that. And then next on my list is a sample code, a sample Python code that actually provisions an EC2 instance on AWS using the default VPC and output the public IP once it's done. We'll actually run this code. I'll show you guys the repository I've put up and actually show you how it works in more details. And yeah, we have the Terraform CDK. So the Terraform CDK is a cloud development toolkit that also allows us to define the cloud formation, our cloud infrastructure using familiar programming language as well. So instead of you going to learn the syntax of Terraform, how you can do this with Terraform, it means you just need to focus on the CDK documentation of actually how to do this in Python or whichever programming languages you're using. And interesting. Interesting. And here's the sample code. This is interesting. How do I do this? How do I fix this? Okay. So yeah, I'll just move on. Since I'll run the demo, I'll just proceed from this. So here's the sample Terraform code. This also set up an EC2 instance and also output the IP once it's done as well. So let me connect to internet. Because we get to general soon. Okay, great. And the last popular item on my list is Pulumi. How many of us here are familiar with Pulumi? I believe Pulumi is actually very popular out there. So how many of us have maybe used Pulumi before? Have even heard of Pulumi at all? Anyone? Okay, cool. So Pulumi also allows us to do the same thing, right? That AWS CDK and Platform CDK does, right? But we can also write it in different programming languages as we want. So really, it all depends on which one sits well with you the most, or which one you resonate with the most. Which of these tools you resonate with, whether it's AWS CDK. The benefit of Terraform and Pulumi is that you can write for any cloud provider with Terraform and Pulumi, but with AWS, it's only specific to AWS. That's the caveat with the AWS CDK compared to others. So here's the sample code written in Python as well. This provision that is to instance, with the public IP once it's done, with the security group included, and yeah, enough talking. Let's actually get to the demo. Sorry. Thank you. So I put up a very small project. Inside my folder, you guys can see I have the AWS folder, the Pulumi folder, the Terraform folder there. And then I do have a bunch of bash scripts that just helps me automate how I actually run the script. So while we get into the details of before we get into the details of what's actually happening here, let me just clear this terminal and run this script. So what this script will do is that this script will go into each of these folders and actually run the Python script that are written for each of the cloud development kits. And I'll get into the details of into the content of the code shortly. So let me just run this while we take a look at that content. So here you can see, welcome to BiOps Orbit. This is provisioning. This is currently running the Terraform script. So we could see the details of everything happening directly here. If you wish to, okay. This is small. These are the things. Okay, so while we wait for this to continue running, I'll just go into the detail of the code, shortly while we wait. So here we have, here's the sample code that actually, I believe you guys can see it clearly, right? Okay, great. So here's an AWS stack code that set up a default VPC, creates an EC2 instance, and then outputs the public IP. So what we'll notice here is that what's actually happening here is let me actually open the Terraform folder since that's the one I'm working on at the moment. This is a symbol of Pycode. So this, by the time this script is done running, we would have, we're going to get an EC2 instance and a T2 micro instance provision on my AWS account with the tag Python doc. And once this is done running, it's going to output the public IP of that instance out on the console. You can't see it clearly. Okay. So let me zoom in. Is it better now? Okay, great. So as you can see, I'm actually leveraging on the CDKTF, which is the Python library for writing Terraform CDK. And here I just define the AWS provider to set my region and then define my root directory, the local backend for my state. And here's the state folder here. And this is where I actually set, I'm actually creating my resources. So I'm defining the state and say, this is the instance type I want. I want to use this AMI, and I want this instance to have this tag. And as you can see, all that is happening, you can see all the plans to actually create everything, and you can see the public IP here. So once the script is actually done running, it's going to provision, it's going to output the public IP properly for us. So let's quickly take a look at the AWS CDK. So the AWS CDK uses similar approach to the Terraform CDK, and they actually have similar syntax somewhat. Here, I am using the default VPC. I'm selecting the default VPC in region US West 1, and I'm creating an EC2 instance in this default region, and also outputting the public IP of that instance as well. So here is the code that actually provisions that on our AWS account. I'm going to show all these instances that we're setting up now on AWS shortly. And yes, here's the Boto library I talked about the other time. So unlike how we had to define the state of our infra using IAC, when using this low-level library of AWS Python library, it means that we can do more, right? We can do more than just creating an S3 bucket. We can use that same library to upload files to the S3 bucket. So IAC just gives you a way for you to define your desired state and to bring up resources to meet the desired state. But if you actually want to do actual, interaction with some of these cloud APIs themselves, you have to use their native libraries for that, or maybe something else that works. Yeah. So this is currently running the Python CDK, AWS CDK at the moment, and once that is done, it's going to move on to the Pulumi setup as well. So let's just quickly take a look at our AWS instances to actually see if we have these instances created here. Oh yes. So we currently have the AWS script running. So yeah, that's currently setting up the instance program and creating the CloudFormation templates for that. So this is the instance we just created for the Terraform CDK. And here's the tag that we set for the EC2 instance on my AWS account. And I also have a script to destroy this provision once I'm done as well. So I'm going to quickly just mention how PipeOps and some of its customers benefit, for all these features of IAC that we've talked about today. So when you're using PipeOps, you guarantee that your infrastructure is provisioned in a consistent way, and all of these features that we've talked about automatically applies to, and you get those benefits when you actually choose to set up a server with PipeOps. So it means all the automation features that we've talked about, to how you set up your IAC, how you define your state, how you continuously run the script, even down to upgrades or maybe your Kubernetes cluster, for example. PipeOps automatically handles all of that for its users. So you can actually focus on what really matters to you, which is building and deploying your project. So I'm actually, while we wait for the Terraform, the CloudFormation script and everything I have here to be done running, I'm going to show a quick demo of how we can deploy a Django project with PipeOps. So I'm going to start by creating the server. So instead of me going to write IAC now to create the server, and then you have to manually set up that server, to run the workload you want to run. With PipeOps now, you can just click on your provision server, click on PipeOps, proceed. So we currently only support the London region. So I'll select London and hit the next customize button. I actually want to create the server plan here on the roadmap. And I'll proceed with that. In less than a minute, PipeOps will give me a ready server, a server that is ready to handle my deployment. So no extra configuration, no extra setup needed. Just create the server and start deploying. So here's the Let's walk through deploying a project now. Hit the new button, click on deploy project, select the web framework, and then I think I'll just deploy one of these popular projects. Then let me just deploy this fast API project. So we have this fast API project. Now I have to select which server I actually want this deployment to go to. So let's go to the new one we just created. Let's proceed. So Python automatically detects that, oh, this repository is a Python repo. So it means you don't necessarily need to do anything else just to deploy this project. Just add your environmental variable and hit the deploy button. And Python will take your code, you build the code, deploy it to the server you just created, and give you a live URL to visit this. So this is something you have to go do ourselves. Just like we set up our EC2 instance right now. If I want to make this EC2 instance carry my deployment, I have to, SSH into the instance, do some manual tweaks, do some edit, install everything I need to get it to serve whatever I want it to serve before I get, or maybe before I even point it to any domain URL whatsoever. But with PyPops, just create a server and deploy a project. Very simple. So as you can see, going back to the instance that we're creating the other time, here is the Python AWS SDK for the AWS CDK script that we're running. So as you can see here, we have the Pulumi script already done, which is so here's the logs of the Pulumi script. Here we can see the plan, the IAC plan of what the infra setup looks like once it's done. So you can see that I set up a VPC, set up a subnet, add a security group, create an internet gateway, create a route table, and I'll show you how we quickly define that in Pulumi shortly. So let me just zoom in so you guys can see. I believe you guys can see this, right? Yes. So here's how we define every single thing that is in this log, right? All this plan that we have here is actually defined in this Python code here. So here's how we define the VPC side that I want to use, and then the AWS EC2 instance, including the internet gateway, the subnet, the route table, just as the plan is listed here, the route table association, the security groups, and the EC2 instance itself. Thank you very much. Welcome to my tech talk. Any questions from anyone?
All right. Thanks for the speech. I enjoyed it. So then, based on 5 goals, when you're developing data structure, normally most services that you have do either you have a level 5 to completion. So you also similar. But the way you demo it, like you just take my code, right? So if there's a particular pattern, for example, if you're looking for means of UI, like something like that, data structure, then you have a 5.
Okay, got it. So the idea of PyPops is that we're trying to eliminate the need for some of these YAML files. That's the idea. So meaning you can really just connect your GitHub and deploy your code. And how that happens is, so we leverage on Buildpacks. Buildpacks is an open source project out there. It's used like Heroku. So just like you deploy to Heroku without the need of a Docker file, we leverage on Heroku Buildpack as well. So you can actually deploy using Heroku Buildpack without the need of any YAML file.
So Heroku, for example, there's a certain structure, the runtime, the profile.
Yes.
So do you need to do those, put those certain files?
Okay. So the idea is whether you have a proc file or not, the deployment will work. You don't necessarily need to define anything for you to deploy, right? But because we support Heroku Buildpack natively, It means if you already have an existing profile, you can
code that my model will run is after PY. So let's say there's nothing like after, everything is model of PY. Am I meant code? I don't know the PY. So what magic do you want to do?
I see. So yes,
That's what it does.
there is a standard structure, yes, for on how this build path detects how to actually start the code. Yes. So what happens is when you don't define, when you can't find maybe the main provide or whatnot, it means it can't find a way to start your app, which is where the profile actually comes in better now. So with the profile, it means so we're not trying to introduce our own YAML, right, or our own profile. So we're leveraging on existing tools that are already familiar with us. So you can easily just plug and play a system into our platform without any additional configuration.
What if there's no profile?
So what if there's no profile then you can actually write your code?
That was not my question.
Your Docker file. Yeah.
Yeah.
Please use the mic.
What field am I supposed to start this app for each one? That means, so if you don't make compose on your end, how definitely going to fail. Right?
Yes.
So do you give the user that error to kill and they need to set up?
Yes. So when I deploy, let's say I'm deploying in a directory now that has no content, or maybe buildback will not detect. You need to get the error. Buildback will not detect the language or framework to use for this.
So you tell it to set up your buildback to their profiles?
No, we currently do not do that. But yeah, that's actually something we'll take on as a
They do support the repository linking.
Oh yeah, sure. So let me just show you that. Yeah, you saw that, right? Yeah, exactly. So see, this is my GitHub. I can select the organization, select the repo, the branch, and all that. Yeah.
That's the last one. Is the last one.
I want to ask a question.
So what you did was my question.
Yes. Sorry. So let's say you probably set everything up. Not the code you showed us. Probably set everything up and yeah, it's working. But I'm running a very heavy model. So and the configuration I set and I want is not on AWS. So it's not a particular one magic anymore. I need a GPU. And I'm sitting down and I'm running it in a small space. How do you want to solve that?
So if I understand the question, you have a GPU that you use to run your workload.
No.
Okay.
I configure my code
Okay.
to using these tools, to use GPU and everything. And now run it anyhow I like it without choosing.
Oh,
You don't do it automatically.
I see.
I got the SAP app and
Oh yes, I see. I see what you're saying. So currently at the moment, right? We're still like experimenting with like deploying AI models in PyPops, right? So at the moment, in fact our chrono plan, which is the global chrono plan on our server, is not generally available to the public. It's strictly based on request. So because what would happen is we're actually planning to support like GPU-based servers on PyPops. So that means instead of you just buying like CPU-based servers, you can actually buy GPU-based servers and you deploy your project into that GPU-based server instead. So that way, you can even pay less for GPU, right, and get the most value. But at the moment, I don't think any of our Sapa and ProPlan can handle everybody else. Yeah.
Thank you very much. Is I there? Okay, the last question. If you want to ask, please quickly.
Thank you very much. I thought this day was actually 2 days ago, so I want to know you guys are fine. Well, I just wanted to, because we already use some platforms, but several Google and stuff, and then the latest we face is actually payments.
True.
SAPA, that's a plan. So like your pricing models, like how expensive, how far, because particularly trying to pay with your card, or those kind of challenges. So like how are you guys managing that?
Okay, so when you sign up on PipeUps, if any of us sign up on PipeUps today, we all get credit. So actually create free servers and deploy projects. So no commitment. But so I'm just going to go your question. Now let's continue.
I just want to know your pricing models.
Okay.
And then
Okay. So let me just quickly show that to you. So when you're purchasing servers on PipeUps, we have the Nova plan, which is the 9K plan. You get one CPU, 1 gigram from there, and it costs you less than 10K. And you can actually pay with this app. So meaning you can pay with your Naira card, you can pay via transfer, and it works. Right. And then we have the Pro plan list, which costs less than 20K. With the Pro plan, you get the 2 gig RAM, 1 CPU. But we rest assured, our pricing is still like undergoing like constant review to actually fit what the user was saying or what generally fits the market. But if you actually turn on your VPN, the pricing you will see will be different. Yes. So yeah, you want to make sure you are not maybe blocking location tracking or so you can actually get the benefits of paying it with PipeUps. Yeah.
Okay, thank you very much. So the next session is at the PSS.